In this video, I will be presenting Scenario Dreamer, Vectorized Latent Diffusion for Generating Driving Simulation Environments, published at CVPR 2025. Existing data-driven simulators such as Waymax or NewPlan rely on pre-recorded driving logs which offer only a slice of possible driving conditions. However, it is important to expose AV planners to a comprehensive set of diverse and interesting test scenarios. For this reason, the research question we aim to answer in this work is how we can augment our set of scenarios for AV planner testing without having to undergo more costly real-world data collection. To solve this problem, we propose to train a generative model to synthesize novel simulation environments for AV testing, thus exposing AV planners to a potentially infinite variety of interesting and diverse scenarios. Our proposed generative simulation environment generator is called Scenario Dreamer. We now show Scenario Dreamer in action. The video on the right shows a scenario synthesized by Scenario Dreamer, where the AV is in red and the surrounding actors are in blue. The scenario is fully generated by Scenario Dreamer and executed in closed loop. We now highlight Scenario Dreamer's unique characteristics. Scenario Dreamer is a fully data-driven generative simulator for testing AV planners and is trained on large-scale, publicly available trajectory datasets. Scenario Dreamer also utilizes fully vectorized processing, which replaces the rasterized encodings of prior work, which we find significantly improves generation fidelity and efficiency. At the core of Scenario Dreamer is the vectorized initial scene generator. The initial scene generator is parameterized as a transformer-based latent diffusion model that operates directly on the vectorized scene elements. This contrasts with prior work that typically encode the initial scene as a rasterized image. We find that fully vectorized processing is crucial for performance and efficiency. We embed each vectorized element, i.e. the centerline vectors and object state vectors, as well as the lane graph connectivity A, into a latent space learned by a VAE, where we process the vectorized elements through a sequence of factorized lane-to-lane, lane-to-object, and object-to-object attention layers. The VAE decodes the latents into initial scenes with a decoder that follows the same architectural structure as the encoder. Once the VAE is trained, we then train a latent diffusion model to sample from the VAE's latent distribution. Novel scenes are sampled by sampling from the latent diffusion model to generate a set of latents, which are then decoded with the VAE decoder. The Scenario Dreamer initial scene generator generates a 64 by 64 meter tile of initial scene conditions. However, oftentimes we would like to simulate for longer than can be simulated in a 64 by 64 meter tile. So to support this capability, we take inspiration from prior work Sledge that utilizes diffusion inpainting to generate longer scenarios for AV testing. As shown below, we can generate an initial 64 by 64 meter tile, select a valid route for the ego, and then renormalize the scene to the end of the route. We can then apply diffusion inpainting to fill in the new part of the scene, conditioned on the existing part of the scene. This inpainting procedure can be applied successively to generate arbitrarily large simulation environments. The Scenario Dreamer initial scene generator supports multiple modes of generation: map-conditioned object generation, full scene generation, and scene inpainting. We compare a random sample of initial scenes generated by Scenario Dreamer with a random sample generated by Sledge. Scenario Dreamer generates higher fidelity and more realistic lane topologies and initial agent configurations, while sampling 3 times faster than Sledge. Here we show scenarios generated fully by Scenario Dreamer, where the AV planner under test is denoted in red. Scenario Dreamer can generate an endless variety of diverse and realistic simulation environments for testing AV planners. To evaluate planning in Scenario Dreamer environments, we train an RL planner and GPU drive, and then evaluate this planner on real scenarios and synthetic scenarios generated by Scenario Dreamer. When we evaluate the RL planner on Scenario Dreamer environments, with route lengths equal to the average route length of the evaluated Waymo scenarios, we observe similar planner failure rates, which indicates a minimal distribution shift between real and generated scenes. However, when we increase the route length of Scenario Dreamer scenarios to 100 meters, we observed a 50% increase in collision rate, And we observe an additional 12% increase in collision rate when we utilize adversarially negatively tilted agents for behavior simulation. These findings underscore the practical utility of Scenario Dreamer as a tool for evaluating and challenging AV planners. Thank you for listening. We highly recommend checking out our project page at the QR code linked to see more cool videos and results.